So if you look at this reactant, you see it right here. You see that there is 1 mole of that reactant, and it is a reactant in this equation, and it's 1 mole here and a reactant. So this value is just going to remain the same, that negative 1,234.7. However, this product in this equation is a reactant. There's 1 mole of each. So because there's 1 mole, we don't have to multiply by 2, divide by 2, or anything like that. But we do have to flip this equation. So we have to get this reactant as a product. So when we do that, this becomes not a negative, but rather a positive. So we'll get rid of that. Now I'm going to write the entire thing out so you can see how each of these things cancel out in order to get the answer for delta H that we're going to get in the very end here. So this equation is going to remain the same, but this equation is going to completely flip. So we're going to have 2CO2 plus 3H2O, and then this CH3O CH3 plus 3O2. All right, so now when we go to cancel all this stuff out, because we flip this, now this is the equation. So the 2CO2 is a reactant here, but a product here. That cancels out. 3 water, reactant here, product here. That cancels out. And then the 3O2 is a product there and a reactant there. So the only thing we're left with that's different is the net equation below. And so when we manipulated these equations, now we have negative 1,234.7 kilojoules and 1,328.3 kilojoules. So when we just add those two values together, let me do that one real quick. 8.3 plus a negative 1,234.7, we end up with a net delta H of 93.6 kilojoules.